Guys, what's up? Today I'm going to talk about min heaps and how to build them from a set of numbers, just in case you guys are asked to actually insert a set of numbers in order into a min heap. So first I'm going to discuss the two main properties of min heaps. The first one is that a min heap must be a complete binary tree. So just as kind of a refresher, a binary tree is a tree data structure in which each node has at most two children, which are referred to as the left and the right child. Then a complete binary tree is a binary tree in which every level except possibly the last is completely filled and all nodes are as far left as possible. So remember, do not confuse complete with full because they're not the same thing. Then the min heap property essentially just means that each node in a tree has a key which is greater than or equal to the key of its parent. So essentially what that means is that the children are going to have a greater than or equal to value than that of their parents, and as you probably already guessed, the root is going to contain the minimum value of the set of numbers. So first, before we start constructing the tree, here we have an array representation of the set of numbers, and there is no number located in the first position of the array. Usually for convenience of implementation of the min heap, usually you will see the first value located in the second position of the array. So just don't let that throw you off if you guys see that. Just know that usually there is no value here. You can safely ignore it. So first, we're gonna insert the first number, which is 6, into the min heap. Next, we start inserting the second value, which is 4. And remember, always insert the value to the left of its parent at first, because if you insert the 4 here, that would be a violation of the complete property of the min heap, which states that the tree must be filled from left to right. So remember, you always want to insert to the left at first. However, here we already have a violation because 4 is not greater than or equal to 6, so we must swap these two numbers because we have a violation of the min heap property, which states that the children must have a greater than or equal to value than that of their parents. And so we insert the next number, which is 5. Is 5 greater than or equal to 4? The answer is yes, so there is no violation here. The next number is 1. And we insert it to the left of 6. However, we can see that 1 is less than 6, so we have a violation of the min heap property. And so we have to swap 1 with 6. However, we have another violation because 1 is not greater than or equal to 4. So we must swap again, 1 with 4. And so the next value that we have is 2. We insert 2 to the right of 4. And we can see that we have a violation because 2 is less than 4, so we must swap these two values. And so our next number is 3. We insert 3 to the left of 5. Okay. That looks really bad. Okay. However, we have another violation because 3 is less than 5, so we must swap again. so our last value is 9, and we insert it to the right of 3. And as you can see, all of the children of every parent has a value greater than or equal to them. So we finally have built the min heap. This is the final result of inserting these numbers in order into the min heap. Remember guys, there's only one possible result from inserting a set of numbers in order. So if you got anything different than this, then you probably did something incorrectly. Now to write the final results, the reason that this is the final result of this min heap as an output is because the way we read this is we go top down, left, right. So we would read it as 1 2 3 6 4 5 9. So that would be the final output from this min heap. So I hope that was helpful, and I hope you guys can understand min heaps a little more now, and that you guys do well in your exam. So good luck guys, and have a nice day.